Today we're going to solve this problem. Find a basis of vector space spanned by the vectors. And we have a set of vectors here. What we're going to do is we're going to convert these vectors into a matrix. Then we'll reduce the matrix to echelon form and find the pivots correspondingly to the columns which contain them. So I'm going to call the matrix A and write it down. 1, 2, 1, 2, minus 1, minus 3, 0, 2, 2, 1, minus 1, minus 2. So we have our matrix A. Let's use simple row operations to reduce the matrix into echelon form. In the first row, we can see that our pivots is 1. And our job is to eliminate every element below it. Very simple. We're going to multiply minus 2 by R3 and add it to R2. We're going to keep the first row, 1, 2, 0, 1, and we get 0, 5, minus 2, and 3, and we keep the third row. Next step, let's eliminate this one. Minus 1 multiplied by R1 plus R3. Again, we keep the first row and the second row. For the third row, we get 0, minus 5, 2, minus 3. So we're finished with our first column. Let's move to the next column. So in the next column, the second column, we can see that our pivots is 5. And our job again, we're going to eliminate every element below it. So this minus 5. Very simple. We're going to add R2 and R3. Then we can have 1, 2, 0, 1, 0, 5, minus 2, 3, and all zeros in the third row. Now we're finished with the second column. And we're going to look at the third and fourth column. There are no pivots, because below 5, they're all zeros, and obviously zeros cannot be pivots. So we got our echelon form. Now we're going to count the pivots. In this matrix, we have 1 here in the first column. Our second pivot, it's going to be 5. And these are the only 2 pivots that we have in the matrix. Now we're going to trace them. The first pivots, it's in the first column, and our second pivot is in our second column. And now we're going to trace these back into the set of vectors that we have. Correspondingly, the first column and the second column corresponds to the first and the second vector. Now we're going to conclude that the basis of span 1, 2, 1, 2 minus 1 minus 3, 0, 2, 2, 1 minus 1 minus 2 equals to, the first and the second vector. It's going to be 1, 2, 1. 2 minus 1 minus 3. And now we're done.